Good morning, everybody. So we're going to go ahead and move forward with the next section that we're going to cover here, which is section 8.2. I'm going to go ahead and split this section into two different parts, just because it's, I'm trying to figure out the best way to approach these lessons electronically, and I just think that splitting it up will be easier to teach it this way. It'll also make it a little bit easier to do the problems. So I'm going to be trying something a little different from last time for our homework this week. Last time I just had you complete a worksheet where I said you could, do it on lined paper, you could take a photo of it. This week, what I'm going to give you guys is a slideshow. It's going to look kind of like the lesson that I'm going to teach you. So I'll actually show you. This is going to be the homework that you're going to receive. As you can see, it's a very small slideshow. It's not a very big lesson for this week. But it's not a long week this week anyways. We're actually not going to have school on April 10th. That's Good Friday. And then next week is spring break. So let me just kind of scroll through and show you what you're going to receive here. So you're going to get a slideshow, and you're going to complete the slides that say you try. Here in red, I'm kind of giving you hints on how you can type your work. So what you're going to do is everywhere where it says type your answers here, you're just going to click it and actually type in your work. And I'm going to guide you through slides that look very similar to that. So as you can see, this is my notes, my slide that I'm going to walk you through in this video. And it looks very similar to the you try slide that you'll do for the homework. So if you're struggling to figure out how to complete a particular slide of the interactive slideshow, just rewatch this video, go to the slide that looks identical in format to the slide that you're working on, and you'll see how I'm typing things out, because I know that can be kind of a challenge, is how to type out math. So let's go ahead and get started. Section 8.2, part of what we're going to be covering in this section is multiplying polynomials. So last time we talked about what is a polynomial, what's the degree of a polynomial, how to write it in standard form, all that good stuff. What I'd like to start by doing as kind of an introduction to this lesson is something that you should be able to do. In fact, I encourage you to pause the video and give these a try on a piece of paper. For questions 1 and 2, I just want you to use the distributive property to simplify. And for questions 3 and 4, I should probably space this out a little bit. There we go. So it's clear to see that this is the question, and then this is where the actual problem starts. For questions 3 and 4, I want you to use properties of exponents. Okay, so two different properties, distributive property, properties of exponents. Go ahead and pause the video and give those a try and see what you get. All right, so at this point, you should have paused the video to give these problems a try. Here's what you should have gotten for numbers 1 and 2. If you're using the distributive property, you're just taking that number that's touching the parentheses and multiplying to each of the inside terms. So 2 times x is just going to give me 2x. 2 times 7 is just going to give me positive 14. Done. I can't solve anything, right? I can't use inverse operations to get the x alone. There's no equal sign. This is my final answer. Okay, so I'm just going to tab over, and I'm going to start typing for question number 2. And I'm going to do the same thing. Negative 10 times 2 gives me negative 20. Negative 10 times 9k gives me negative 90k. So as you can see, this is kind of how I type out my work. Sometimes I put a little space around the minus sign so it's nice and clear. But I figured this would be a little bit easier if I just show you how to type in the slides, if that's how I'm going to ask you to do your work. I'll also show you how to do the exponents as well. So actually, if you see, when I went and I hit the enter button, it's still formatted as an exponent. I don't want that. So I can actually show you right now. I believe you go to Format, Text, Text, and I'm going to select the superscript to actually turn the exponent off. See how it made my cursor a little bit bigger there? That's going to be regular font. All right. Properties of exponents. This is where you want to go back to your notes for chapter 7. So I've got k cubed times 3k cubed. So when you're applying properties of exponents, you're going to multiply the coefficients. Coefficients are the big numbers that sit in front of your variables. And if you're multiplying two bases, and the bases are the same, if you recall, you can add the exponents together. So there's an understood 1 in front of this k right here. I'll just put it in red so we know that that's something that I just added in. So I'm going to multiply. 1 times 3 gives me a coefficient of 3. And then I know I've got a variable k. And then to get my exponent on that variable, I'm going to take this exponent and add it with this exponent. 3 plus 3 gives me a final exponent of 6. So I'm going to go to Format, Text, Superscript, and type in my exponent. Yes, there are keyboard shortcuts, but I don't know if you guys are using the same type of computer that I am. I am on an Apple computer, so if I try and tell you what shortcut to use and you're on a Windows, it's not gonna be the same thing. So I'm just gonna do it the old-fashioned way so everybody can see how to do this. So that's my final answer here for number 3. Number 4, same idea. All of my bases are the same. So I can use properties of exponents to simplify this expression here. All of my coefficients, 4, 2, and an understood 1, I'm going to multiply those together. 4 times 2 times 1 gives me 8. And then I'm going to have an m, and then my exponent, I just add. 2 plus 3 is 5. 5 plus 4 is 9. So I need an exponent of 9. Format, text, superscript, 9. There's my final answer. Okay. So if you can do the distributive property, if you know how to multiply things, and you can do properties of exponents, then you can do this lesson because it's kind of combining both of those things. So last time we talked about monomials and polynomials. A monomial is just a number, a variable, or the product of the two. A polynomial can be a monomial, or it can be more than one monomial that's being added and subtracted together. Okay, so all we're going to focus on today is how do you multiply a monomial, one little term right here, with a polynomial. Okay, here's my polynomial, 6a plus 6. In fact, I could even ask you to name the degree of this polynomial, the one that I'm highlighting. So if I just look at this polynomial that I'm highlighting, what's my degree there? Well, remember, if you're trying to figure out the degree of something, you'll look at the variables, and in this case, I only have one variable, and it's going to be the highest exponent within that polynomial. Well, if I only have one variable, it's going to be the exponent on that variable. My exponent here is an understood 1. So this is a degree 1 polynomial, which makes it linear, and it's a binomial because there's two terms. And I'm multiplying it with a degree 6 monomial, okay? And it's a monomial because it's one term. So I want to simplify this, and essentially you're going to be distributing this term, this whole term, into each of these two terms. So you're going to do like we did in numbers 1 and 2. You're going to use a distributive property, and then to figure out what those products are, you're going to have to then use what we did for 3 and 4. You're going to use the properties of exponents to simplify the exponent on the variable. Anything that's a coefficient, you're just going to multiply the old-fashioned way. Okay, so I'm going to do number 1 with you. Whoops. So 2a to the power 6 times 6a. Well, these coefficients of 2 and 6, I can just multiply those together. 2 times 6 gives me 12. And then I know I'm going to have an a, and then to figure out what the exponent of that is, I'm going to have to take this exponent and add it with the understood exponent that's here, which is a 1. Okay, you may even want to add that in. I may want to add that in here. I'll make it red so that way we know that that's something I added in. Okay, so 6 plus 1, well, that's going to give me 7. Let me go to my superscript. There we go. And now I also have to turn it off. Otherwise, it's going to stay on. All right, so far so good. Now I need to get the second product. I'm going to multiply these coefficients. 2 times 6 gives me 12. It's going to be positive, so I'm going to put a plus sign. And do you notice how this one doesn't have an a? That's okay. I'm still going to have to include this in my product. It's kind of like saying a to the power 6 times 1, because there's nothing there. There's an understood 1. So a to the power 6 times 1 is just going to give me a to the power 6. Now I can't combine these, right? I can't add these and say that this is 24 a to the power 13. Okay, some of you guys were trying to do that in the last homework assignment where you had a plus or a minus sign in between two terms and you guys were trying to use properties of exponents on this stuff. You can only use properties of exponents when you're multiplying, okay? If there are plus and minus signs, all you can do is combine like terms, assuming they are like terms. Well, I can't actually combine these because they're not like terms. They both have an a, but the exponents don't match. Okay, in order for things to be like terms, the variable has to match and the respective exponents on those variables have to match. There's nothing more I can do with this polynomial. This is considered done. Hopefully that clears things up from last time. I'm going to tab over and do the next one. All right, so same thing here. Anything that's a coefficient, you'll multiply. Anything that's a variable, you're going to add the exponents. 6 times 3 is going to give me my coefficient of 18. B to the power 4 times b squared is going to give me b to the power 6 if I add those exponents together. And then I keep going. 6 times negative 6 is going to give me negative 36. And then I've got a variable, b to the power 4 times an understood b to the power 1 is going to give me b to the power 5. Hopefully you guys will be pros at inserting exponents. You're seeing me do it a million times. All right, 6 times 5, that's going to give me my next coefficient of positive 30. And same thing like last time, there's no b on here, but that's okay. It's kind of like saying b to the power 4 times 1, right? Not 0. If this was 0, there wouldn't be a term here at all. So b to the power 4 has to be included in my product. And same thing like last time. I can't combine any of these terms. This is a b to the 6, this is a b to the 5, this is a b to the 4. They are all different terms. None of them are alike. I would not use properties of exponents because these terms are not being multiplied. They're being added and subtracted. Okay, you can't use properties of exponents like that when things are being added and subtracted. This entire polynomial is my final answer. And it's also in standard form. This one's in standard form as well. We want to get in the habit of writing polynomials in standard form. We learned last time that a polynomial is in standard form if the exponents on the variables decrease left to right. In other words, the degrees of the monomials decrease left to right. So this is standard form because I have an exponent of 7 followed by 6. They're decreasing left to right. All right, let's look at something a little different. Right off the bat, you probably notice these look a little more complicated, and that's because they have more than one variable, okay? So it's kind of like a matching game. I'm going to use properties of exponents on matching variables. So for number 3, for example, I have an x and I have a y squared. When I multiply these first two terms, I can only use properties of exponents on matching variables. See how the first term inside the parentheses here only has an x? That means when I use properties of exponents against this term, I'm only going to apply that property to the x. The y squared is just going to come down for the ride. Kind of like how in this problem on the previous slide, the b to the power 4, when I multiplied these last terms, this b to the power 4 came down for the ride. This a to the power 6 in number 1 came down for the ride. okay? Similar here, if there's no y, the y squared is still going to come down for the right of my product. All right, so same thing as last time. I'm going to multiply the coefficients. 3 times 8 is going to give me a coefficient of 24. And then x to the power 1 times an x to the power 1. I can add those exponents together and get an x to the power 2. And then y squared, there's no y in this term, but again, it's like y squared times 1. I just lost my normal font. Let me turn it back on. Come on. I don't want an exponent right now. There we go. It's just going to be y squared times 1. That's just going to give me y squared. There we go. This is another reason why I wanted to keep the slides, the lessons a little short. It can take a little time to type everything out. It's not like writing it on paper. It's a bit of a challenge. All right, next product, 3 times negative 6, that's going to give me negative 18. And now this one doesn't have an x, so I'm just going to have x to the power 1 times an understood 1. Well, that's just going to give me x to the power 1. You can write the 1 in if you want. I'm not going to bother. It's understood to be there if I don't write it. I can simplify these y's, however. I have a y squared and I have a y to the power 1. Remember, if there's no exponent, it's an understood 1. So 2 plus 1, that's going to give me y to the power 3 if I add those exponents together. Here's my final answer. I can't combine these. Yes, they both have an x and they both have a y, but the exponents on not just one of the variables, but both of them don't match. This is an x squared, this is an x. This is a y squared, this is a y cubed, okay? Don't worry too much about trying to write things in standard form when they have multiple variables. Someone actually asked me in email, how do you know, they were like asking, how do you know, I think what the degree is if there's more than one variable. I think that might have been what they were asking. I don't remember. I'd have to go back and look at the email. I'm not going to have you worry too much about figuring out how to write something like this in standard form. There is a way to figure it out. For those that are curious, you would just add the exponents here. So this would mean that this is a degree 4 monomial, but this is also a degree 4 monomial. So there's really no way to write this in standard form if both of those are the same degree. Either way would work, I guess. All right, so I'm going to tab over. I am still as a superscript and I don't want that. Okay, so number 4. There's an understood 1 here. So I'm going to write that in. And I'm going to multiply my coefficients. 3 times 1, well, that just gives me 3. And I have some a's that I can simplify. A squared times a squared, if I add those exponents, that's going to give me a to the power 4. And then there's no b, so I'm just going to take that b and bring it down for the ride. Next product, 3 times 8 is going to give me 24. A squared times a to the power 1 is going to give me a to the power 3. And then b to the power 1 times b to the power 1 is going to give me b to the power 2 when I add those exponents. Remember, every time you do this, you're adding the exponents together. All right, 3 times 3 is going to give me 9. There's no a variable on this term. There's no a, so this a squared is just going to come down for the ride. A squared just comes down for the ride. And then I keep going to simplify the b's. B to the power 1 times b squared. If I add those exponents, it gives me b to the power 3. And then just kind of glancing over, there's no like terms. I can't add or subtract any of the terms here. This is an a to the power 4, a to the power 3, a to the power 2. None of these terms are alike. Same thing with the b's, b to the power 1, b squared, b cubed. None of these are alike. I can't add them all together and use properties of exponents to get one monomial. You can only simplify things using properties of exponents if you are multiplying. Okay, so that's done. That's my final answer. And that wraps up our lesson today. So to recap, all we learned today was how do you take a monomial and multiply it with a polynomial by combining both of these properties, the distributive property and properties of exponents. So I've decided to try and do more online friendly assignments. You'll give the interactive slideshow that I'm going to attach to Google Classroom a try. And then I've assigned a few Khan Academy assignments. If you log into Khan Academy, you should see this assignment. Here's the name, and this assignment. I believe I've made that due for Wednesday as well. Give all of these problems a try. As is usual, let me know if you're running into any issues. You can either comment on the assignment in Google Classroom. I think you can send me a private comment on Google Classroom. You can email me. And if push comes to shove and you really just need me to kind of walk you through in real time, shoot me an email. We can always set up a one-on-one Google Meet, and I can try and walk you through that way as well. Okay, that's going to wrap up our lesson for today. Take care.